For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
Today we're going to learn about a new operator, that's the implication operator. It simply means if P is true, then Q also has to be true. Another way to read it is if P, then Q. You might also see the implication operator written like this, but it's the exact same thing. If we want to make a truth table for this, again, we have two propositions. So we're going to have a column for the two propositions that we have, one for P, one for Q, and then we're going to have one column for the compound proposition because that's the actual thing we want to find the truth values of. How many rows do we need? Well, the number of rows is equal to 2 to the n, where n is the number of propositions that we have. We have two propositions, so it's going to be 2 to the second power, which is 4. So we're going to have 4 rows. How do I fill up the truth table? Take the number of rows, which is 4, divided by 2, write it down here, and then keep dividing by 2 until you get to 1. This number tells us how many trues and falses we're going to have to start off with, and you always want to start with trues. So we're going to do 1 true, 2 true. I used up all of my trues, so I move on to my falses. 1 false, second false. I used up all of my falses. I have no space left, so I move on to the next column. This number tells me I'm going to start off with 1 true and a false. 1 true, I used up all my trues. 1 false, I used up all my falses, but I still have space left. What do? I copy the same pattern that I just wrote until I ran out of space, and I ran out of space, so I'm done with this column. Now, how do we find the truth values for P implies Q? I think of P implies Q as a contract. And how does a contract work in real life? Well, it says if something happens, then you have to do something, and then you sign your contract. The rules of the contract are if you violate the contract in any way, you fail it. You broke the contract, so you're going to get false, F for failure. Otherwise, you'll get a true. And it's best with an example. Again, we don't actually need to know what the propositions are to do a truth table, but with this, it's really good to think of these two propositions. It is raining as proposition P, and I bring my umbrella as proposition Q. So the contract is going to say, if it is raining, so if P, then Q, and Q is I bring my umbrella. So you sign the contract that if it is raining, you will bring your umbrella. So if you violate the contract somehow, you're going to get an F for failure. Otherwise, you'll get a true. So let's go through this. Here, P is true and Q is true. P being true means that it is raining. And what does your contract say? Your contract says that if it is raining, then you should bring your umbrella. Did you bring your umbrella? Yes, Q is true. You haven't violated the contract, so you get a true. Here, P is true, so it is raining. What does your contract say? It says if it is raining, which it is, then you should bring your umbrella. And yet, Q is false. That means you did not bring your umbrella, so you violated your contract, so you get an F for failure. You failed to meet the condition of your contract. Now here, P is false. That means it is not raining. What does your contract say about it not raining? Nothing. You signed a contract to do something if it is raining. So if it's not raining, in both of these cases, then you haven't violated your contract at all. So otherwise, it's just true. So think of true as passing your contract. Either you fulfilled your contract because it is raining and then you did bring your umbrella, or simply you just did not violate it because it wasn't raining. So you had no conditions to violate. So otherwise, it's true. So always remember these two propositions, and that's going to help you out. But if we just focus on the truth table, no matter what this variable is, it could be S, it could be Q, it could be T, but whatever this is, if it's false, it's always going to be true. And the only other way it's true is if you fulfill the terms of your contract. For example, if I had another implication, S implies T, I'll do 2 columns for my 2 propositions, and then 1 for the compound proposition. Because we have the same number of propositions, it's going to be the exact same setup. So true, true, false, false, true, false, true, false, and then I look at this and I'm just going to look for when it's false. It's false here and here. That means it's going to be true here and here. And the only other way it's true is if it passes the actual definition of an implication, which is if S is true, then P should be true. And we see that here. So then this is true, otherwise it's false. So that's another way to think about it. Now let's go over some implication vocabulary, and this is going to be very useful in one of the applications of propositional logic, which is translating sentences into propositional logic like this, which we will have a whole video on, but we'll do 2 examples here just to show you what that's about. In an implication, the first thing that you see before the implication operator is what we call the premise. Think of pre as it coming before the implication. Then the last thing you see is what we call the conclusion. Think of conclusion as it comes at the end, so it comes after the implication. You can also think of it in terms of the contract. The premise comes first, and then the conclusion is at the end. Another name for the thing that comes at the end, or the proposition that comes at the end, is the necessary condition. And that makes sense if you think about it in terms of the contract, because whatever comes after the implication is necessary. Like, you need to do this. So that's why we call it a necessary condition, because we're saying if P is true, then you have to do Q. You signed a contract. So it's a necessary condition. And then P we call the sufficient condition. So let's try some examples. We're going to translate the following sentences into propositional logic. Here we have a necessary condition for photosynthesis is the presence of sunlight. Before you think about anything, just identify what your propositions are. Here they're not written as propositions, but you can rewrite them as propositions. For example, photosynthesis is the first thing I see, so I'm going to say proposition P is photosynthesis occurs. That's a proposition because it could either be true or false. Either photosynthesis occurs or it does not. Then I see the presence of sunlight. As a proposition, that can be sunlight is present, because sunlight is present can either be true or false. Either the sunlight is present or it's not. And then how do we translate that into propositional logic? So I know it's an implication because I see necessary. If you saw sufficient, it would also be an implication. But then the question is, which of these go where? Does P go here, Q go here, or does Q go there and P goes here? They're telling us that the necessary condition for blah 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 is the presence of sunlight. That means that this proposition Q is a necessary condition. So recall, where does the necessary condition go? After the implication, which is why Q will go after the implication and P will go to whatever place is left. And so we're left with that proposition P is our sufficient condition because it is before the implication. Let's try one more. A sufficient condition for passing an exam is scoring above 65%. First, I'm going to identify my propositions as I see them. So first I see passing an exam. So as a proposition, that is the student passes an exam, or you could say I passed the exam, however you want to interpret it. But it has to be something that can either be true or false. So it could be true or false that the student passes an exam. And then scoring above 65%, you can have it as the student scores above 65%. It could either be true or false that the student scores above 65%. So it is a proposition. Now, how do I translate that into propositional logic? Well, again, I see sufficient conditions, so I know it's going to be some sort of implication. But then the question is, does P go here and Q here, or does Q go here and P here? Well, it tells you that the sufficient condition, which is the first thing before the implication, and by thing I mean proposition, is scoring above 65%. And that's this proposition Q. So what goes in the box before the implication is Q, and then whatever's left, which is P, goes after the fact. So we're not saying that P is always a sufficient condition, or that Q is always a necessary condition. We're saying that whatever's here is always a sufficient condition, and whatever's here is always a necessary condition, but they can be different variables. In this case, Q actually ended up being the sufficient condition because we defined it as such. If this was Q and this was P, it would be P implies Q, because then P would have to be the sufficient condition. So that's it on translating and a little bit of vocab. In the next video, we'll talk about variations of implications like converse, inverse, and contrapositive.